If you like our content, please like, subscribe, and click the notification bell to get alerts when we introduce new videos.
So this is module 7.04, where we're specifically now going to look at how the LNS and the API interface from an application level. So as we look at our LoRa network interface and our LoRa network, we have our sensors connected through our gateways and into our LoRa network server. That is all now taken care of and onboarded. But as we start looking at how we onboard the sensors and how we use the sensor data, we have to now bring the data out of the LoRa network server and into our application server. So we provide the data using a standard REST API format, and there are a couple of things that are used to authenticate and provide connection and authentication for the devices within the network. So the first thing is that you have to, on the application server interface, you have to connect to the WebSocket and to the interface and provide user information about who and what sensors you're specifically interested in. So we make a request in on port 7000 and we provide the information about which owner we are, who the user are, and which sensors that we're interested in. The data itself will be presented on port 7002, and again we make the call by authenticating using the owner name that we can request as part of the authentication process. And then finally we're going to get a data stream that is sent out on the port 7002, and that will provide us with all the information about the sensor, the payload, and the information about which device and which access point gateway it's connected to is all provided within the actual payload coming out into the application server. So in addition to authentication and connection to the LNS, one of the key things we have to do is we have to actually understand the data and the payload that we're receiving. So each vendor has a unique way of dealing with the payload and presenting that information. Because LoRa is designed to be a very low data rate network, and it's designed to be a very, very long battery life, the focus really is on reducing the amount of time that the sensor is transmitting, and therefore the manufacturers try and integrate as much data into a compressed format for the payload as possible. So if a sensor, for example, a door sensor that we have here, has 4 or 5 pieces of information that it wants to send, instead of sending 5 different messages, what it does is it takes those 5 values and compresses them all into a single 8-byte message. Now this is a very efficient way of sending quite a lot of data, but it does require your application server has to do some extra work to decode that data. So as we look at this particular sensor, the first byte provides us our status. So within that byte, we're actually only interested in bit 0. So bit 0 within the first byte provides us an open or closed indication. The next byte provides us the battery level. But again, instead of just providing us the battery level, we want to have 2 pieces of information. We want the battery voltage and the battery capacity. So again, we use the lower 4 bits to provide the battery voltage and the upper 4 bits to provide the battery capacity. Temperature is presented in the next byte. So again, we're only really interested in a few of the bits. So we use bits 0 to 6 for the temperature and the temperature range, and then bit 7 is not particularly used in this example. And then we have another 16 bits we're using to represent the time. So this is since the last trigger event, and this is partly because LoRa may have multiple instances where events have happened, but it can't send all of those at the same time due to the time on the air usage and fair usage policy. So what it'll actually do is it'll wait until it's allowed to transmit, and then it will tell you how long ago that event actually happened. And then the final thing we have is just a generic counter of the total number of events that have been triggered. So you really need to understand how to decode the payload before you can actually do much with the data coming out from the API. We've got our LoRa network server running, and we've got a gateway connected. So we have our Tech-Telec Kona gateway that's connected to the LoRa network server. Then in addition to that, we have our tabs door sensor connected to the Tech-Telec gateway and in through the Tech-Telec into the LoRa network server. Now we actually want to do something useful with the data. So what we're going to do is we're going to forward all of the messages from the LoRa network server into our rules engine and actually do something useful. So here we're going to bring up our rules engine, okay, and you can see we have our rules engine running, and we actually have the data. This is a WebSocket that's connected to the IoT controller, and we'll see if we modify that. So it's a WebSocket connected to the IP address of our IoT controller on port 7002 and the owner ID of the port that we're connecting to. Okay, the output of that will be a text string. So what we'll do is we'll view that text string coming in here, and you can see every time an event comes in from the LoRa network server, it comes in as a text string. That will then convert to a JSON structure, and we'll be able to output that here as a JSON message. So if I trigger the door sensor, you'll get a message coming in, and this is the JSON formatted data. So you can see all the information about that sensor, its current state, its MAC address or device EUI, the current counter, number of events, frequency, and then the payload. Now the payload is fully encoded, so we need to go in and decode that payload. And we do that by using just a small piece of code here. So we're going to go in and we're going to take our payload message and we're going to convert it into bytes, and then we're going to strip the bytes out and break them up into relevant pieces. So that one message actually provides about 5 or 6 different pieces of information. So our code can break each of those bytes out and provide the device EUI, the status, so true or false, the battery level, the current capacity of the battery. If the sensor provides it, it will also provide the temperature, the time, and any counter information. So just using a little bit of JavaScript here, we're able to basically take an incoming message from the sensor and output that to our payload, or so we can view it. So again, I'll trigger the door sensor and you'll see the message comes in and we can see the current status. So we've decoded that, all of that message string. We see the device EUI, we see its current state is true because I've just opened the door contact, battery level, capacity, temperature, time, etc. So now it's very simple for us to, using this 3 or 4 nodes and a little bit of Java, to now take a message coming in from a sensor and forward that information and do something with it within our rules engine.